Hello, welcome to this new YouTube video. In this video, I would like to show you the R55 project and how I add a new feature to emit events, which is how it's done in Solidity. I will show you exactly the change it made in each field so you can get an idea of how this code works. And of course, I encourage you to participate in the development of any open source project that you may be interested in. Okay, I have prepared a short summary that shows you the different changes in the PR. Let's take a look at the change I have made step by step. In content deriv, leave ers. In RC20, leave rs. The change. In R55, access.rc, main rs, errors. In Ethereum runtime and Ethereum Syscall and leaves rs and logs. You can view. And step by step the functionality now what I develop. And this is the principal PR, Syscall log and event optimization. Introduction implementation of log Syscall of event, emission and RISCV contract, emit macro with automatic solidity type detection and signature generation, testing in RC20, and this is the PR. Okay, let's see the first change in contract deriv in leave per s. You can see in content deriv the different changes I made. This is the code in content deriv leave as. Okay, I will explain you the first change I made in contract deriv in leave.rs. This is the change, and I will explain you the significance. Okay. In macro event deriv, automatic events. First, we have the event deriv macro. This macro helps you create event and force tree. Events are essentially for recording information on chain, like state change, transfer, or any action you want to log. With this macro, you can define an event in a super simple way and it generates all the code needs for it to work properly. What does that event deriv do? Let's say you want to record the transfer in your contract. You'll define something like on file for from, another to, one more for value, for example. You might also want from and to be indexed, so they're easy to search for. When you use the macro, it automatically generates the event signature. For example, something like transfer address in 256. Split the data in two groups. The topics, which are your indexed field like from and to, and the non-indexed data, such as value. Compute the event hash. It uses the KeyCAG 256 algorithm and set the hash as the first topic. Encode everything in the proper format for the on-chain logs. The macro showStream. It prints the attribute and content that a macro receives to the console. For example, if you are unsure about what data a macro is processing or how it's been transformed, you can use this macro to inspect it. And the macro contract. Now we come to the most important macro contract. This is the one that turns your logic into a fully functional smart contract. Automatic everything you will normally have to read manually. When you define a smart contract, you need to make this method accessible from outside, decode argument, handle payment, and much more. This macro takes care of all that what is content do? Imagine you have a simple method in your contract, like one of the double of number. With this macro, you only define the logic of your method and automatically generates a unique selector. This is an identifier that the blockchain uses to know which function you are calling. The code to decode the arguments. For example, if something called young function from outside the contract, the data comes in encode. The macro generates the code to decode it properly and pass it your method. 3. Handle return value. If your method returns something, the macro encode it and sends the block to the caller. A deceiver. This is like a big match statement that connects its selector to its corresponding method. In short, you define your logic and the macro handle everything else. The second change I made in RC20 leverage. This is a simple smart contract like a RC20, and that I have made is a who you can log and emit events like this in the function transfer. In log emit transfer new from to value in this in the ref event in this struct equal the 3 chains I made in Ethereum RISC runtime in lever-s and logger-s. In lever-s, the unique change I made is the implementation, the log implementation like this. And the Ethereum RISC runtime src log. This has you can view the different event in the struct in the RC20 and who works internally. The 4 chains in Ethereum RISC Syscall in lever-s. It's only at the log in the Syscall. You can see the chains. And my favorite part, the tests. The test I made for works the functionality. This is the test I made. In this test, transfer logs, the principal setup, my print, only selector, or the verification the event logs is works correctly. And the 5 changes made is in R55 XRC main point RS and errors. Error, this is a custom error. Exec, this is the logic we have implemented for works in the code, the Syscall log and the internal logic. And now let's run the test transfer logs, like rest transfer binary, deploy, and transfer log. And I can show the test is completely successfully. And voila. Okay, I hope you enjoy the video. I know I am still new to speaking on camera, but I'm really excited to keep improving and finding better ways to explain things. Every video is a step forward, and I appreciate you being here with me on this journey. If you like the content, don't forget to like, subscribe, and hit the notification bell to support the channel and stay updated. And as always, feel free to leave your thought or question in the comment. I would love to hear from you. Thanks so much for watching, and I will see you in the next one. Thanks.